Hi everyone, welcome to the channel. In our today's video lesson, we are going to discuss the topic cubes. Cubes is a very important topic for any given competitive exams today. Let us start from the basics. Let's understand how this works. Cube, which is a three-dimensional figure. Let it be a cube which is a three-dimensional figure. Now my question is, how many corners does a cube have? How many corners does a cube have? This is known as a corner. For any given cube, you will find 8 corners. How many edges does a cube have? The line which joins two corners is known as an edge. You will find 12 such edges. And then, how many faces does a cube have? Face is a square which is formed with 4 edges. This is what known as a face. You will find 6 faces. Cube is a three-dimensional figure. Number of corners that you observe are 8. Number of edges 12. Number of faces 6. And then let me give you a question now. Do understand this question. Try to solve this question and post your answer in the comment section. Very good evening, Pandu. Welcome to the channel. Let us understand this question now. A cube is decorated in such a way that one diamond is placed at each corner, 5 diamonds on each edge, 3 diamonds at the center of every face. Then we need to find the total number of diamonds on that cube. Let us solve this question. So let's assume that it's a required cube now. So cube is decorated in such a way that one diamond is placed at each corner. So on any given corner, let's say for instance, you are given one diamond. So as far as corners are concerned, you will find 8 diamonds. So one diamond is placed at each corner. 5 diamonds on each edge. As this is an edge, you are given that on any given edge, there are 5 diamonds. Among these 5, if you guys can understand this, we are done with these 2 diamonds earlier and you are left with 3. 3 on each edge. You are given that 5 diamonds on each edge. Among these 5, we are done with these 2 earlier. So once you count a diamond, that cannot be counted again. So we need to consider any of the given diamonds exactly once. So once you count it, you are not allowed to consider the same thing again. So on an edge, we are left with only 3 diamonds, which we need to consider now. And we know that 12 edges on a cube. So it's 12 into 3, which gives you 36. So as far as edges are concerned, you will find 36 diamonds. And then 3 diamonds at the center of every face. As 3 diamonds at the center of every face, let it be this way, 3 diamonds at the center of every face, and as we have 6 faces. So as far as faces are concerned, 3 on each face, 6 such faces. So total number of diamonds will be 18. So total number of diamonds now, putting these 3 numbers together, it's 8 plus 36 plus 18, which gives you 8 plus 36 is 44. 44 plus 18 is 62. So total number of diamonds on a cube are 62. Hope this is clear. That brings me to the next question of, let us understand and solve this question. Read the question once. Do understand this question once. This time, a cube is decorated in such a way that one diamond is placed at each corner. If this is the cube, you are given that one diamond is placed at each corner. So as far as corners are concerned, so in this question, I noticed one more thing here. So cube is decorated with diamonds as well as pearls. Diamonds as well as pearls. Corner, edges, faces. So let us calculate diamonds separately and pearls apart from diamonds. Now, one diamond is placed at each corner. So as far as corners are concerned, you will observe 8 diamonds, 3 diamonds and 2 pearls on each edge. Let's understand this. 3 diamonds and 2 pearls. Let's say 3 diamonds and 2 pearls on each edge. So let us look at it this way. As far as 3 diamonds are concerned, among these 3, we are done with these 2 diamonds earlier. So we already considered these 2 diamonds. Now we are left with only one which is need to be considered now. On each edge, you will observe only one new diamond. So 1 on each edge, we have 12 edges. So it has to be 12. And then faces. How many diamonds we have at the center of every face? How many diamonds we have at the center of every face? 3 pearls and 1 diamond at the center of every face. As 1 diamond at the center of every face, 6 faces, you will find 6 diamonds on the cube now. So total number of diamonds are 26. Now let's have a look at pearls. As far as corners are concerned, no pearls are put at the corners. And then 3 diamonds and 2 pearls on each edge. So on each edge we have 2 pearls. So 2 times 12, that's 24. Hope you guys are with me. And then 3 pearls at the center of every face. As 3 pearls are placed at the center of every face, as there are 6 faces, 6 times 3, it's 18. So total number of pearls are 18. So total number of pearls on the faces are 18. And total number of pearls are 42. So what are we expected to find now? Find the square of the difference between pearls and diamonds on that cube. Here, let's understand this question. We need to find square of the difference between pearls and diamonds. So let us try to find the difference first. Diamonds 26, pearls 42, difference between these two is 16. And then we need to find square of the difference. Difference is 16 and we need to find its square. That's 256. So 256 is the square of the difference between pearls and diamonds on that cube. Hope this is clear. That brings me to the next question of, if you guys have any queries with any of the questions, do mention that in the comment section. Drop a message there. Your doubt will be clarified. Now, a cube is decorated in such a way that one flower is placed at each corner. Let us draw a cube again. If this is the cube, a cube is decorated in such a way that one flower is placed at each corner. Let it be a flower. One flower is placed at each corner. 2 flowers and 1 diamond on each edge. 2 flowers and 1 diamond. So let it be the diamond now. 2 flowers and 1 diamond on each edge, 2 flowers and 3 diamonds at the center of every face. 3 diamonds, and along with this 2 flowers and 3 diamonds at the center of every face. Find the product of flowers and diamonds on the cube. In order to answer this question, we need to find total number of diamonds, and along with that we need to find total number of flowers as well. So the given question is about flowers and diamonds. So we need to find the number of flowers and number of diamonds present on the cube. Again, we need to follow the same order: corner, edges, faces. Now, let us focus on number of flowers used to decorate this cube. 1 flower is placed at each corner. So as far as corners are concerned, you will find 8 flowers. And as far as corners are concerned, you will find 0 diamonds. No diamonds are kept at the corners. 2 flowers and 1 diamond on each edge. As 2 flowers on each edge, we are done with those 2 earlier. So we need not count anything now. So nothing to be considered on edge now as far as flowers are concerned. And then 1 diamond on each edge. So 1 on each edge. So total number of diamonds will be 12. 2 flowers and 3 diamonds at the center of every face. As 2 flowers at the center of every face, 6 faces, 6 times 2, it's 12. And then as far as diamonds are concerned, 3 diamonds at the center of every face. So 3 times 6, it's 18. So total number of flowers, 20. Total number of diamonds, 30. Now we are expected to find the product of these two. Product of flowers and diamonds. So it has to be 20 into 30, that's 600. So I am sure you guys will be able to solve any of the questions based on this particular pattern. You can easily solve questions from this. Now, let us get into the topic now. Let us dig deeper. Let's understand a square first. Now we are going to discuss the heart of this topic. Previously, the previous model is all about to get used to number of corners, number of edges, and number of faces. And another important thing there, once a diamond is counted on the corner, it cannot be considered on the edge again. So once you count it, that's counted forever. So that's what we need to remember. So that's a learning from the previous model. And this time, let us discuss about a square, and then let us get into a cube on the same thing. So usually you will find questions of this kind. How many parts will be obtained when a cube is cut once? If you make one cut on a cube, how many parts will be obtained? Here, the basic assumption is when you cut a square or when you cut a cube, let us talk about a square first. The only difference between square and a cube, square is a 2-dimensional figure. As far as a cube is concerned, that's a 3-dimensional figure. Cube is a 3-dimensional figure, square is a 2-dimensional figure. So 2-dimensional figure is to do with x-axis and y-axis. Now, let's understand this. If you make one cut on a square, you should make it either through x-axis or else through y-axis. You're not allowed to make the cut in any of the remaining things. So you should cut it either through x-axis or else through y-axis. If you make one cut on a square, the resultant figure will be either a square or a rectangle. That's what we need to understand. If you cut a square once, the outcome will be either a square or a rectangle. Look at it once. Once you make one cut on a square, how many parts will be obtained? 2. If you make 2 cuts on a square, how many parts will be obtained? If you make 2 cuts on a square, let's understand this. 2 cuts can be done in 2 different ways. You can cut through the same axis, or you can distribute the cuts to two different axes. If you make two cuts through the same axis, you will get three parts. That's a possibility. If you distribute the cuts between the given two axes, you will get four parts. So 3 being the minimum and 4 being the maximum. Hope you understood this point. Let me repeat. If you want to get minimum number of parts, we need to cut it through the same axis. When our outcome should be the maximum, if you need to get maximum number of parts, then we need to distribute the cuts between the given two axes. This time, 3 is the minimum, 4 is the maximum. Let us discuss about minimum first. Once we get used to it, then we shall move on to the next one, maximum, finding the maximum number of parts. If you make three cuts on a square, how many minimum parts that we get? When we make three cuts, I want you to make the three cuts through the same axis. So you will get 1, 2, 3, 4, 4 parts. When 4 cuts are done on a cube, when you make 4 cuts on a square, when you make 4 cuts on a square, you will get 5 parts. For n cuts that we make, we will get n plus 1 parts. That's being the minimum. Here, the thing which we need to remember is, in order to get the minimum number of parts, we need to make the cuts through the same axis. If the desired output is to get the maximum, we need to distribute the given cuts between the given two axes. Clear? Let's understand this once. When two cuts are done on a square, as shown in this example, as shown on the screen now, you will get 4 parts. When we make 4 cuts, how many maximum parts will be obtained? 2 cuts through x-axis, 2 cuts through y-axis and 2 cuts through x-axis, you will get 3 parts this way and 3 parts this way. That's 9. So let us understand this. I want you guys to generalize this. Do remember this point. If you make 6 cuts on a square, how many maximum parts that we get? 3 cuts through one of the axis and the remaining 3 cuts through the other axis. So once you make 3 cuts through y-axis, you will get 1, 2, 3, 4 parts here. Once you make 4 cuts through x-axis, you will get 4 parts here. And total number of parts obtained will be 16. For 6 cuts that you make on a square, 16 parts that you get as the maximum. Fine. And then, if you make 8 cuts, when 8 cuts are done on a square, you will get 25. I am sure you guys noticed a similarity among these things. All these numbers are perfect squares. 2 square, 3 square, 4 square, 5 square. Now, I am sure when you are given a number which is a bigger one, that's not possible for us to draw a diagram this way. This is not manageable. If that's the scenario, how do we calculate that? Then how do we do this? Simple. Do understand this point now. I'm always talking about two axes, x-axis and y-axis. The same thing that's shown on this figure. Let's say I have chosen this example now. 6 cuts, 3 through x-axis and 3 through y-axis. The thing that we said now, 3 through x-axis and 3 cuts through y-axis. Do understand this point now. When you make 3 cuts through x-axis, that results 1, 2, 3, 4 parts. When you make 4 cuts through y-axis, even this results 4 parts. If you need to find the total number of parts obtained, you need to multiply 4 into 4. As we got 4 through x-axis and 4 through y-axis, we need to multiply these two things. That's 4 into 4, which gives you 16. That's simple. Now, if you come up with a number, a bigger number, let me consider this example now. If it is 2n, n cuts through x-axis and n cuts through y-axis. So, when you make n cuts through x-axis, that results n plus 1 parts here. Here you will get n plus 1 parts. And your answer will be product of these two, that's n plus 1 whole square. So, when we make 2n cuts on a square, the maximum parts that we get are n plus 1 whole square. Clear? Hope this is understood. Now, a doubt may come across your brain now. Do understand this point now. If this doubt strikes your mind, uh, the doubt is how will we get to know that it's the maximum? Let me pick one example of 11 or let's say 12. If you make 12 cuts on a square, in how many ways 12 cuts can be done? 0 cuts through x-axis and 12 cuts through y-axis, this being one of the possibilities. And then 1 cut through x-axis, 11 cuts through y-axis, this being the second example, second way of doing 12 cuts. 2 cuts through x-axis, 10 through y-axis, 3, 9. So what are we doing now? I am increasing the value in this direction. That's obvious. This value will be decreased. So sum of these two should always give you 12. It can be 0 plus 12, it can be 1 plus 11, it can be 2 plus 10, it can be 3 plus 9. Another possibility 4 plus 8, another possibility 5 and 7, another possibility 6 and 6. Now we can stop it here. The reason being 7 and 5, you'll get this thing again. My final output will not affect. Clear? Do understand this. When we make 0 cuts through x-axis, you'll get one part. As we discussed earlier, when you make n cuts through x-axis, parts obtained will be n plus 1. That's the basic learning, which we discussed earlier. In the same way, if you make 0 cuts, that remains the same. It don't affect the square. The square will remain as a square, so we need to consider it as one part. And 12 cuts through y-axis, 12 cuts through y-axis results 13 parts. So here, my answer that's going to be 13. Hope you guys understood this point. Let's work on this now. 1 cut through x-axis, 11 cuts through y-axis. If you make 1 cut through x-axis, that results 2 parts. If you make 11 cuts through y-axis, that results 12 parts. So total number of parts obtained will be 24. I am sure 24 is bigger than 13. 2 and 10. So my output will be 3 into 11. Now we have got 33. 3 and 9. It's 4 into 10. That's 40. 4 and 8. 5 into 9. 45. Hope you guys understood why I'm increasing this number. When it's 4, it's 5. When it's 8, that's written as 9. So n cuts through x-axis results n plus 1 parts. N cuts through y-axis results n plus 1 parts. You guys need to put this in your brain. And then 7 times 7, 49. If you observe these numbers, if you come across all these numbers, you guys can notice that 49 is the maximum and 13 is the minimum. 49 being the maximum, 13 is the minimum. So when 12 cuts are made on a square, as we discussed earlier, 12 which is need to be divided in this way 6 into 6. So it's 7 into 7. We got the same result again. We need to understand that if the difference between these two numbers, the difference between the cuts that you made through x-axis and y-axis, if it is maximum, the output will be number of parts that we get. If you consider this as the output will be the minimum. Clear? If the difference between these two keep on decreasing, so difference between 0 to 12 is 12. Difference between 1 and 11 is 10. 10 is less than 12. Here it's 8. Here it's 6. And here it's 0. So difference between the cuts that you make through x-axis and y-axis is minimum. The output, I mean the number of parts that we are going to get, will be the maximum. So this is a basic learning here. If the difference between the cuts that we make between x-axis and y-axis, if you reduce the difference, the output will increase. So this is one of the important things which I expect you guys to remember. Along with this, let us look at another important point here. That is, if someone asks you to find minimum number of parts that we get, I am sure we can answer this. This question can be answered. If someone asks you to find maximum number of parts, believe me, even that's possible. We can definitely answer this question. If someone asks you how many parts that we get when we make 12 cuts on a square, how many parts that we get when you cut a square 12 times, if we make 12 cuts on a square, your answer will be cannot be determined. As minimum or maximum is not mentioned, such questions cannot be answered. This is the proper answer for that. we can declare the minimum number of parts, we can determine the maximum number of parts, but the numbers that we are going to get between minimum and maximum cannot be figured out. So you guys need to remember this point. So this is one of the important learnings from this topic. And then, so previously we discussed about even number of cuts, and if it is 2n, we concluded that maximum parts will be n plus 1 times n plus 1. What if the given number of cuts are an odd number? Let us say, for instance, 5 cuts. How many maximum parts that we are going to get when we make 5 cuts on a square? Same as we did earlier, 5 cuts are to be distributed between x-axis and y-axis. 5 should be distributed this way, 2 cuts through x-axis and 3 cuts through y-axis. As 2.5 and 2.5 is not a valid thing, we need to distribute it this way, 2 cuts through x-axis and 3 cuts through y-axis. When we make 2 cuts through x-axis, you'll get 3 parts. When we make 3 cuts through y-axis, you'll get 4 parts. And your answer will be 3 times 4, 12. Hope this is clear. I need your confirmation. People who are active in the class, please do mention that in the comment section. Are you guys able to follow the class? If you guys have any queries, you guys can write it in the comment section. Each and everyone active in the class, do drop a message in the comment section. Thank you for the confirmation, Ramapi. Nice. I'm awaiting the response from the other guys as well. Let us see now. 5 cuts, you'll get 12 parts. If we make 7 cuts on a square, 7 should be distributed this way, 3 and 4. When it's 3, you'll get 4 parts. When it's 4, you'll get 5 parts, and your answer will be 20. 20 is the maximum. We are always talking about the maximum here. So when we make 7 cuts on a square, the maximum parts that we are going to get is 20. So 2n plus 1. Any given odd number can be expressed this way, 2n plus 1. So n cuts through x-axis, n plus 1 cuts through y-axis. Here we'll get n plus 1 parts, here we'll get n plus 2 parts. The same thing that we have done here. 2n plus 1 should be distributed this way, 3 and 4. For 3 cuts that we make, we get 4 parts. For 4 cuts that we make, we get 5 parts. So we understood how it works on a square. Now let's discuss about a cube. The difference between square and a cube, as we discussed earlier, cube is a 3-dimensional figure. As far as a square is concerned, that's a 2-dimensional figure. Cube is a 3-dimensional figure. So another axis comes into the picture now. That's z-axis. So x-axis, y-axis, z-axis. Previously, when we discussed about a square, the given number of cuts are to be distributed only between x-axis and y-axis. But this time, if you guys can understand this, the given number of cuts are to be distributed equally among x, y, and z axis. So we need to distribute it among x, y, and z axis. So if we make 6 cuts, let me start with 3 cuts. If you make 3 cuts on a cube, 3 cuts are to be distributed this way, 1, 1, and 1. 1 cut through x-axis, 1 cut through y-axis, 1 cut through z-axis. Which results 2 parts through x-axis, 2 parts through y-axis, and 2 parts through z-axis. And total number of parts that we get are 8. So if we make 3 cuts, maximum parts that we get on a cube are 8. So if we make 6 cuts on a cube, how many maximum parts that we get? 6, which is to be distributed this way, 2 cuts, 2 cuts, and 2 cuts. That results 3, 3, and 3. So the answer will be product of these 3 numbers. That's 27 parts. So for 6 cuts that we make on a cube, maximum number of parts that we are going to get are 27. If 9 cuts are done, 9 will be distributed this way, 3, 3 and 3. So the output will be 4, 4 and 4. So your answer will be 4 into 4 into 4. That's 64 parts. Let us try to generalize this now. If you make 3n cuts on a cube, 3n cuts on a cube, 3n will be distributed this way, n, n and n. So it's n plus 1, n plus 1 and again n plus 1. So your answer will be product of these three numbers, that's n plus 1 whole cube. So this can be generalized this way. And this works when you are given a number which can be expressed in the form of 3n. Now, if it's not in the form of 3n, a number, any given number, can be expressed in one among these three forms. It can be in the form of 3n minus 1. A number can be expressed in the form of 3n or 3n plus 1. Any given number can be expressed in exactly one among these three forms. 3n minus 1, 3n or 3n plus 1. Now, we are done with one of the forms, that's 3n. When we make 3n cuts on a cube, the maximum parts that we get are n plus 1 whole cube. What if you are given a number which is not in the form of 3n? Let me pick this example now. If it's in the form of 3n minus 1, let us see how it's going to work now. If the given number is in the form of 3n minus 1, let me pick one example. Let's say 14, x-axis, y-axis, z-axis. If 14 cuts are done on a cube, how many maximum parts that we get? 14, which is need to be distributed this way, 14. So it's 5, 5 and 4. I am sure 14 is the number which is in the form of 3n minus 1. That's 3 into 5 minus 1. So if it is 15, if I had given 15, I would have written it as 5, 5 and 5. But this time you are given 14, which is 1 less than 15. So instead of 5, I have written 4 at the end. So 5, 5 and 4. So 14 cuts are to be distributed among the given three axes this way. And the result will be 6, 6 and 5. So your answer will be product of these three things. That's 180. So when we make 14 cuts on a cube, the maximum parts that we get are 180. And then let me pick some other example of 17. If we make 17 cuts on a cube, how many maximum parts that we get? 17 is to be distributed this way, 6, 6 and 5. So the final output will be 7, 7 and 6, product of these three numbers. It's 294. Once this is understood, I am sure you guys will be able to find for these numbers as well. If it is 22, that's in the form of 3n plus 1, 7, 7 and 8. This is how we distribute 22 cuts among the given three axes. So it's 8, 8 and 9. Product of these three things will be our answer, and it's 576. Hope this is clear. That brings me to the next model now. Let us discuss the next model from this topic. If a cube is painted, read this question once. 27 small and identical cubes are put together to form a large cube. You guys can imagine a cube of this kind. In the question, it is mentioned that we have 27 cubes, and all the 27 cubes are put together to form a large cube. So you guys can assume a Rubik cube, or if required, I can show you how to draw a cube of this kind. I want you guys to draw it along with me. Draw a square first and give an extension this way. If you consider the cube this way, now as 27 small and identical cubes, from this we need to understand that 27 is nothing but 3 cube. 3 cube. As it's 3 cube, it is required to make 2 cuts through x-axis, 2 cuts through y-axis and 2 cuts through z-axis. So let us make 2 cuts through x-axis. Let's make two cuts through y-axis, and then let's make two cuts through z-axis. Let us draw a cube as shown on the screen now. This is the output. So if you consider a cube as shown on the screen now, let us solve this question. 27 small and identical cubes are put together to form a large cube. This is the required cube. This large cube is painted on all its 6 faces. Find how many small cubes have no painted face, exactly 1 painted face, exactly 2 painted faces, exactly 3 painted faces. Let me start with this. Exactly 3 painted faces. So here we need to understand that 3 faces of a cube can be painted only when the cube is kept at the corner. You guys can clearly notice this. That's being one of the faces, this being the second face of the same cube, and this being third face of the same cube. 3 different faces of a same cube. And this takes place only when the cube is kept at the corner. How many such cubes that we observe? One at each corner. So you will observe such a cube on this corner as well, at this corner as well. So you will find 8 such cubes. One at each corner, you will find 8 such cubes. So answer for the fourth one, exactly 3 painted faces, is 8. Now let us work on this question. Exactly 2 painted faces. So 2 faces of a cube can be painted only when the cube is kept on the edge. Observe this one carefully. For this cube, it's painted on exactly 2 faces of it. So this being one of the faces of the cube, and this being the second face of the same cube. And no other face of this cube can be painted. So exactly 2 faces are painted, and this takes place only when the cube is kept on an edge but not at the corner. Clear? If someone asks you, in this cube, how many cubes are placed on an edge? Your answer will be 3. And how many cubes are exactly 2 faces painted? Your answer should be 1. Among those 3 cubes which are kept on the edge, 2 are done with the corners. Clear? So we need not consider, or we should not consider, the cube which is kept at the corner when you count exactly 2 painted faces. So we need to clearly understand this. There's a lots of difference between these two. So exactly 2 faces of a cube can be painted only when the cube is kept on any given edge, and that cube should not be put at the corner. So you will find 1 such cube on each edge. We have 12 edges, so 12 times 1, my answer will be 12. Hope this is clear. If you guys have any queries, you guys can mention that in the comment section. Now, let us work on the next one. Exactly 1 painted face. Exactly 1 painted face. You will notice such a cube at the center of the face. If you guys can connect this with the first model that we discussed, that's the foundation to solve questions of this kind. So 1 cube at the center of every face. You will find 1 on each face. So 6 faces, my answer will be 6. Now do understand this point once. Maximum number of faces that a cube can be painted is 3, and that too when it is kept at the corner. And minimum number of faces the cube can be painted is 0. That's the hidden cube. Which is kept at the center. Fine. How many hidden cubes we have? The things which are visible can be counted with ease and comfort. The things which are not visible, the things which are imaginary, that's somewhat difficult to count those things. So that's the reason we will calculate it this way. Do understand this logic. Do remember this logic. Total number of cubes given 27. Among these 27, I am sure if you pick any cube at random among these 27, that cube can be painted on 3 faces of it, that being one of the possibilities. It can be painted on exactly 2 faces of it. It can be painted on exactly 1 face of it, or it cannot be painted. So these are the only 4 possibilities which exist. So among these 4 possibilities, we are done with these 3 earlier. So I am sure, except these cubes which we counted till now, all the remaining cubes which are hidden will be no face painted. So total number of cubes given 27, among which 26 cubes are painted somehow, which means that we are left with only one cube that cannot be painted. So my answer will be 1 for the first one. No face painted, our answer will be 1. Hope this is clear. I'm awaiting your response. Do write your answers in the comment section. Are you guys able to follow this? If this is not clear, please let me know. If this is not clear, do let me know. I'll explain the same again. Yes. Thank you, Rama P, for the confirmation. Sure. I'll give you another question now. So let me put another question on the screen, which I expect you guys to solve. This time we have 125 cubes. And all the 4 questions remain the same as earlier. I expect you guys to come up with the answer. I want you guys to solve this question now. Be quick. Previously, that's about 27 cubes, but this time it's about 125 cubes. You guys can write your answers in the comment section once done. Let us see now. 125 cubes are given now. We have 125 cubes now. So among these 125 cubes, yes, Rama B, I think all the questions that you have answered are correct. Let us see now. Fine. Exactly 3 painted faces. So exactly 3 painted faces, that happens only with the corner. So you will find 8 such cubes. Exactly 2 painted faces. Exactly 2 painted faces is something to do with the edge, and we need not count the cubes which are kept at the corners. So 3 on each edge. 3 times 12, we have 36. Exactly 1 painted face. So exactly 1 painted face, that happens, if you guys can notice this, we have 9 such cubes on each face and 6 faces in total. So your answer will be 6 times 9, 54. And then no painted face. Putting all these numbers together, you will get 98. Total number of cubes given 125. Difference between these two is 27. So no painted face will be 27 cubes. Now, let us try to generalize this. Once we generalize this, we can we can draw a formula. N, no face painted, exactly one face painted, exactly two face painted, three face painted. As we understood, there are only four possibilities what we have, and when you are given 3 cubes, when you are given 5 cubes, and when you are given k cubes. Do understand this. No face, let me start with this 3 face painted. It's 8, it's 8. Even for this one, it's 8. Make sure that the value of k is more than 2. And then exactly two face painted. When it's exactly two face painted, I am sure that's related to number of edges. So my answer should be a multiple of 12. My answer should be a multiple of 12. Previously, in the questions that we discussed, for 27, for 27, exactly two face painted, answer being 12. For 125, answer being 36. Do you understand this? Here answer is 12. Here the answer is 36. So that's 12 into 1. Here it's 12 into 3. So it has to be 12 into k minus 2. When it's 3, it's 1. When it's 5, it's 3. So when it's k, it has to be the same way. That can be related this way. 12 into k minus 2. Exactly one face painted. We know that one face painted is the one related to given number of faces. So my answer should be a multiple of 6. 6 into something. Even here, it has to be 6 into something. Now let's understand what this particular number is. When it's one face painted, for 27 cubes, our answer is 6. But for 5 cube, for 125 cubes, your answer is 54. 6 into 9. 9 in terms of 5, that can be written as 5 minus 2 whole square. Let us understand this once. Do understand the basic thing here. When it's exactly one face painted, if you count the total number of cubes on this face through y-axis, I mean this way, we left 2. 1 on the top, 1 on the bottom. So out of 5, we considered only 3, which means that we ignored 2. So you ignore 2 through y-axis, you ignore 2 through x-axis. Out of the total number of cubes that are present through y-axis, we left 2. Out of the total number of cubes that are present through x-axis, we ignored 2. So in the same way, 5 by 5 by 5, you will find 5 cubes through x-axis. That's you need to leave 1, that's 5 minus 2. Same is the case with y-axis, that's 5 minus 2. So 6 into 5 minus 2 whole square. Here it's 6 into k minus 2 whole square. Let me write it here again. 6 into k minus 2 whole square. No face painted, that's 3 minus 2 whole cube. When it comes to this, that's 5 minus 2 whole cube. Here it's k minus 2 whole cube. This is how we generalize this. Now, based on this, I expect you guys to answer this question and post your answers in the comment section. Now, let us discuss this question. "125 small but identical cubes are put together to form a large cube. This large cube is painted on all its 6 faces such that two opposite faces are painted in blue, two adjacent faces are painted in green, and the remaining are painted one in blue, the other in red." If this is the required cube, let's assume it this way. 125 small and identical cubes are put together to form a large cube. This is how it happens. This large cube is painted on all its 6 faces such that two opposite faces are painted in blue. Yes, let it be painted in blue. As two opposite faces are painted in blue, the opposite face, I mean the bottom face, will be painted in blue now. Two opposite faces are painted in blue. Two adjacent faces in green. Let's assume these two now, let it be painted in green. And this face, let it be painted in green. Two opposite faces are painted in blue. Two adjacent faces are painted in green. And the remaining are painted, one in blue, the other in red. When the remaining are painted, one in blue, the other in red. Let it be blue. And the other in red, which means that the only face that we are left with, the one which is hidden behind, this is painted in red. So this is our basic assumption here. Let us understand this again. Let me explain the same thing again. See, 125 cubes are in total. Two opposite faces are painted in blue. Two opposite are painted in blue. So this being one of the faces and this being the second one. Two adjacent faces are painted in green. The face that you are facing and this one, these two are painted in green. And the remaining are painted, one in blue, the other in red. Let this face be painted in blue and the face which is behind, which is hidden, is painted in red. This is our assumption now. And we have total 125 cubes. Now let's try to answer these questions now. How many cubes are painted in 3 different colors? If you guys can understand this, a cube being painted on 3 faces of it is different from the cube which is painted in 3 different colors. You guys need to understand the difference between these two. Let me repeat. A cube can be painted in 3 different colors, but it may not be painted. A cube can be painted on 3 faces of it, but it may not be painted with 3 different colors. But a cube which is painted in 3 different colors will be painted on 3 faces of it. Hope this point is clear. Hope you understood this point. Okay, let me give you an example. Let us discuss with an example. If you consider this particular cube, 3 faces of it, if you consider these 3 faces of it, this is painted in blue, this is painted in blue, this is painted in green, and this is painted in green. So this cube, it's painted on 3 different faces of it, but not in 3 different colors. So this cannot be considered as my answer now. So we need to understand this. When you solve a question on cubes, especially it's about this particular model, when you come across a question of this kind, you guys need to strictly follow this order, corner, edges, faces. You need to put it on the paper this way: corners, edges, faces. This is the one which will avoid the confusion. So how many cubes that are kept at the corners are painted in 3 different colors? How many cubes that are kept at the corners are painted in 3 different colors? So among the given 3 colors, one being blue, second one being green, and the third one is red. So among the 3 colors mentioned, red should be painted on one of its faces. So I am sure red is painted on only one face of the given cube. So my answer should be related to this particular face. On any given face, a maximum of 4 corner cubes will be found. Among these 4 corner cubes, let's assume this ones. If you consider this particular cube, the top face is painted in blue, this face is painted in green, and this face is painted in red. Hope you understood this point. The cube which is kept at the color which is painted on the top, that's blue. The one to your left, that's green. The one which is behind, that's red. So this particular cube is painted in 3 different colors. So this is the cube which has 3 different colors on it. Now let us look at the cube which is opposite, which is parallel to this and which will be placed somewhere below this. Clear? Let's talk about this corner cube now. Hope you guys can imagine this particular corner cube now, the one which is parallel to this down bottom. So the bottom face is painted in blue and this face is painted in green and the behind one is painted in red. So that's being one of the corner cubes. So these 2 corner cubes are painted in 3 different colors. Let us work on this now. If you consider this particular cube, this is painted in blue, that's for sure. This is also painted in blue. So I can definitely tell you this cube doesn't hold with 3 different colors. This cube doesn't have 3 different colors on it. So this will not be considered as my answer now. Clear? Let's work on this particular cube now. This is painted in blue. The bottom one is also painted in blue. So even this cube doesn't hold 3 colors on it. So my answer will be 2 here. So as far as corners are concerned, we found only 2 cubes. And I am sure you will not find any such cubes on edges. Any given cube that is kept on an edge but not at the corners will be painted in exactly 2 different colors but not 3. And one face, at the center of the face, the cube will be painted in exactly 1 color. So we need not bother about this now. So total number of cubes that can be painted in 3 different colors, that are painted in 3 different colors in this case is 2 now. So answer for the first one is 2. Now let us look at the second question. How many cubes are painted in exactly 2 different colors? As we discussed earlier, we need to strictly follow this order: corner, edges and faces. I am sure you will not find any such cube on faces. So center of the face, the cube can be painted in exactly 1 color. But the question being asked about exactly 2 different colors. So the cubes which are faced at center of the faces will not come into the picture now. We can ignore those cubes now. So we need to look at the cubes which are kept at the corners and the cubes which are kept at the edges. As far as corners are concerned, the possibilities are, on any given corner, you will find a cube with 3 different faces of it which can be painted. So 3 different faces of a cube can be painted in 4 different ways. First one, it can never be painted. It cannot be painted. Second one, 3 faces of a cube will be painted in exactly 1 color. Third one, 3 faces of a cube will be painted with 2 different colors. Fourth one, 3 faces of the cube will be painted with 3 different colors. So these are the 4 possibilities which exist. Among these 4, for the given particular question, no corner cube is unpainted. No corner cube is left unpainted. So we need not bother about this possibility. Among the given 8 cubes, you will not find any cube that's not painted which is kept at the corner as far as this particular question is concerned. Let us look at the second one. The corner cube which is painted in exactly 1 color, that happens only when 3 mutually adjacent faces are painted in 1 color. 3 mutually adjacent faces. I am talking about this one. If you guys can consider this face, even this face should be painted in 1 color. Did that take place now? No. Which means that among the given 8 corner cubes now, there is no possibility such that a cube can be painted in exactly 1 color. I'm talking about the corner cube, the cubes which are kept at the corners. Fine, you will never find a cube that's painted in exactly 1 color as far as this particular question is concerned. So we need not bother about this possibility as well. So they are the only 2 things which come into the picture now. So between these two, I am sure we have exactly 2 cubes which are painted with 3 different colors. We had done with this one earlier. So that's for sure. The remaining 6 cubes which are kept at the corners will be painted in exactly 2 different colors. So it has to be 6. Now, edges. how many cubes are placed on the edges and are painted in exactly two different colors? Let's understand this. We are done with the corners earlier. Now we need to focus only on the cubes which are kept at edge, and corner should not come into the picture now. So on any given edge, you will find three different cubes now, three cubes now. As I am least bothered about the cubes which are kept at the corners, we have only three cubes now. So three cubes on each edge, you will find 12 such edges, the maximum possible answer being 36. So I am sure my answer should not exceed 42. But if you guys can understand this, I have considered each and every cube that's been put on the edge. But what is the required thing now? The cube which is painted in exactly two different colors. So out of these 42, now I will try to figure out the cubes which are painted with exactly one color. Fine. I am sure this face is painted in blue, even this face is painted in blue. So we considered these three earlier. Among these 42, you will find these three. So these three are to be subtracted. Same is the case with this edge now. This is painted in blue, even this is painted in blue. So we need to subtract these three as well. Same is the case with the green and green combination here. So three such cubes. So it's 42 minus 9, which gives you 33. Let us look at the third question now. If you guys have any queries, you guys can write it in the comment section. Feel free to ask me a question. Clear? So now the cubes which are painted in exactly one color. So exactly one color. Again, we need to strictly follow this order: corners, edges, faces. So no corner cube is painted with exactly one color. We need not bother about this. And then as far as edges are concerned, how many cubes which are kept at the edges but not corners are painted in exactly one color? If someone asks me this question, I am sure previously we subtracted this 9. Hope you guys remember this point. This is painted in blue, even this is painted in blue. This face is painted in blue, even this face is painted in blue. That's the reason we subtracted 3 here, and we subtracted 3 here, we subtracted 3 here. So these 9 cubes got subtracted from 42. The reason being, these 9 cubes are placed at the edges but are painted in exactly one color. For the previous question, as it's not required, we subtracted these 9. But this time, as it's really required, we need to add these 9. And then, one face painted. One face painted will be painted in exactly one color. So, center of the face. So, 9, 1, 2, 3, and then, yes, 9 on each face. 6 times 9, 54. As far as faces are concerned, you will find 54 such cubes. So, your answer will be 63 for the third one. Fourth one, how many cubes are painted in blue? I am sure the total number of cubes are 125, or we can count it this way: number of cubes which are painted in blue. As far as this face is concerned, we have 25 cubes which are painted in blue. As far as this face is concerned, we are done with this cube earlier. Observe this one once. We are done with this earlier. So this and this are two different faces of the same cube. As we counted this, we need not count this again. So we are left with 1, 2, 3, 4 vertically, 1, 2, 3, 4, 5 horizontally. So we have 20 such cubes which are painted in blue. And then same is the case which is going to happen with this particular layer as well, the bottom face. As you are done with these 5 earlier, so this can be ignored. So 4 by 5, you will find 20 such cubes which are painted in blue. So on the whole, we have 65 cubes which are painted in blue. 65 cubes which are painted in blue. And then not painted in blue. I am sure out of 125, 65 are painted in blue. Out of 125, 65 are painted in blue. So the remaining cubes are not painted in blue. So my answer is going to be 60 for the fifth one. 60. Sixth one, painted in red or green but not blue. Let's understand the difference between the fifth and the sixth questions. You guys need to be very clear in this regard. As far as the fifth question is concerned, we consider the cubes which are not painted in blue. Among these cubes, we have some cubes which are not painted at all. But this time, cube should be painted on red, cube should be painted either in green, but not in blue. As the cube should be painted, no face painted. The cubes which are hidden should be subtracted from the 60. So among these 60, you guys should understand is the 60 cubes are not painted in blue. Among the 60, the hidden cubes will also be considered. As the hidden cubes are also the part of 125 cubes. Previously, we have done this. Out of 125, we have subtracted the cubes which are painted in blue. So we got to know that 60 cubes are not painted in blue. Same is the case with this question as well. But this time, we need to understand that among these 60, we have some cubes which are not painted at all. Those cubes being 27. So 60 minus 27, our answer is going to be 33. So cubes which are painted in red or green but not in blue are going to be 33. So we are done with the topic cubes. So I am sure as far as cubes are concerned, we can solve any of the questions based on that. Cuboids is a different topic. So that's an extension for cubes. So we will cover the topic cuboids in one of the coming next sessions. Thank you so much for watching this video. And I want you guys to follow this channel for more such videos. And then if you guys have any queries, if you want to learn any of the topics, please do mention that in the comment section. Your doubts will be clarified, and the topics that you mentioned, we will definitely take sessions on those topics as well. Thank you so much for being interactive. See you all soon in the next video.